Namaste and welcome to Code Divinity. I am your coding friend Om, and today we are going to solve an easy level problem on LeetCode, that is valid anagram. In this problem, we will be given two strings S and T, and our task is to find whether both of these strings are anagram to each other or not. If it is anagram, then we will return true. If it is not an anagram, we will return false. Now let's see what is an anagram. Two strings S and T are said to be anagram to each other if all the alphabets which are occurring in S are exactly equal to the occurrences of same alphabet in T. In that case, we will say that both of these strings are anagram to each other. Now let's take an example of an anagram. So our first string is loop and second string is pool. The arrangement of the alphabets does not matter. Now the unique alphabets in loop are L, O and P, and for pool it is P, O, L. Now L is occurring once here and once here as well. O is occurring twice here and twice here as well, and P is occurring once and once here as well. So we can say that both of these strings are anagram to each other. Now let's take an example of a non-anagram string. Rat and car. So unique occurrences are R, A, T, and each of them occur once, and in car each of the alphabet occur once. Now we can see that R is equal to R, A is equal to A, but C and T are not matching with each other. In that case, we will say that both of these strings are not an anagram to each other. Now for the edge cases, there can be string S and T where the length of both the strings are not same. For example, stool and tool. Here the size of this string is 4 and this string is 5. So both of these strings cannot be anagram at all. Now let's formulate the algorithm for this problem. For this problem statement, we will use a special data structure called hash map. Hash map is a special kind of data structure as the value stored in a hash map can be fetched in big O of 1 time complexity. So it is a very fast data structure and uses index to fetch the value. In the hash map data structure, we store the data in the form of key value pairs. Now for our problem, the key will be the alphabets which are occurring uniquely in each of the string, and the value will be the count of those or the occurrences of those in the string. Let's take a hash map for string S and a hash map for string T. For example, our string S is tools and string T is stool. Now the unique alphabets in both of them are T, O, L, S, and for the string T, the unique alphabets are S, T, O, L. Now T occurs once, so we will increment the count of T as 1. O occurs twice, so we will put 2. L occurs once, so we will put 1, and S occurs once, so we will put 1. Now for the string T, S occurs 1, so we will put 1. Then T appears once, so we will put 1. O appears twice, so we will put 2, and L occurs once, so we will put 1 here. Now count of S is same, count of T is also same, count of O is also same, and same for the L. So we can say that S is anagram to T. Now let's formulate the algorithm for our problem. If size of string S and T are unequal, in that case we will return false right away, because if the strings are of unequal lengths, then they cannot be anagram at all. Then if the string are of equal size, then we will declare two hash maps. Hash map for S and T, and both of the hash map will be of size 26 and it will be filled with zeros, because there can be 26 alphabets and initially the count of all the alphabets will be 0. Then we will start a for loop from I equals to 0 to size of S It can be size of s or t, doesn't matter because the size is same that we have checked before. Within this for loop, we will be operating over two hash maps that we have declared before, hash map s and hash map t. And for both the strings, we will fetch the alphabet by s of I and t of I respectively, and this will map to the index between 0 to 26 in the hash map, and then we will increment the count. And finally, we will run a for loop from I equals to 0 to 26, and in this for loop we will check whether the hash map s, hash map t are equal or not. If at any point there is inequality between these hash maps, we will return false, because the inequality indicates that the strings are not anagram to each other. And finally, in the fifth step, if we have completed all the checks and there is no inequality in the strings, so we will return true here. Now let's code it on the LeetCode platform. So this is the problem on LeetCode, valid anagram. Let's read the problem statement now. Given two strings s and t, return true if t is an anagram of s and false otherwise. So we will be provided two strings s and t, and we have to return true if t is anagram of s, and if it is not the anagram, we will return false. So they have given the explanation for what is an anagram, but we have already discussed it before, so we will not spend time on it. Now let's take the look at the examples given here. They have given the string s as anagram and string t as nagaram, and the output is true because the number of occurrences of each alphabet in s is exactly equal to the number of occurrences in t. And for the example 2, they have given rat and car, but as we can observe that there is no t in this string and there is no c in this string, so they are not anagram to each other, hence we have to provide the output as false. Now let's check the constraint. The string will be at least of length 1 and can go up to 5 into 10 power 4. Both the strings will have only the lowercase English letters, so that's actually better for us because the hash map size will be 26 and it will consist only of the lowercase letters. Now the problem statement is clear to us and we can begin our coding. We will declare an integer s size which will store the size of string s, and we will calculate it using s.size function. Now our edge case is if both the strings are of unequal size, in that case we have to return false. So if s size is not equals to size of t dot size, we will return false. Now if they are of equal size, we have to perform more checks on it to check if it is anagram. We will declare two hash maps, hash s of size 26, and we will set all the elements as 0. In C++ we can set all the elements in an array as 0 by enclosing 1 0 in the curly braces. This is a smart trick to save some time, and this can be done without writing any for loop. Now similarly we will define a hash map for the t string as well and set all the elements to 0. Now we will begin a for loop from 0 to size of our string that we have calculated before. Now for the hash map s and hash map t, we have to calculate the index of the alphabet. There are 26 alphabet, so it will definitely fall within the indices 0 to 25, and we can calculate that using s of I minus small a. This statement will result into indices 0 to 25. So for example, s of I is a and a minus a will provide a 0, so the 0th index will be selected for the hash map s. And for the hash map t, we will do the same thing. t of I minus alphabet A, and we will increment that position. Now when this for loop will be completed, all the alphabets that are occurring will be incremented, or we can say that the count of that alphabet will be increased in the hash table. And finally we will start a for loop int I equals to 0. It will go up to 26, and we will start comparing both the hash tables together, and it can be done by if hash of s of I is not equals to hash of t of I. In that case we will return false, because if they are unequal, they are not anagram to each other. And finally, after performing all the checks, if there is no inequality found in both, we can return true to the console that both the strings are anagram to each other. Now let's run this code to check on our test cases. So it is running successfully on both the example cases here, and now we can submit it to check on all the private test cases. So our solution is working perfectly on all the test cases, and it beats about 70.16% of solutions. So I hope you like this solution. We will try to solve another question very soon. Thank you so much. I will meet you in the next one.